Disclosure. This educational content has been developed using artificial intelligence.
Welcome back to the channel. What if I told you that everything in the universe, the screen you're looking at, the air you breathe, even US, actually digital, not smooth and continuous, but made of tiny, indivisible chunks. This isn't science fiction. This is the world of the quantum, and it's the most accurate description of reality we have. What is quantum? Look at the world around you, a flowing river, the light from a lamp. It all seems so smooth and continuous, doesn't it? But what if I told you that this is an illusion? What if, at the most fundamental level, the universe isn't a smooth, flowing stream, but is instead made of tiny, indivisible chunks? This is the world of the quantum. It's a concept that shattered classical physics and gave us a new, bizarre, and incredibly accurate picture of reality. And it all starts with a simple, yet profound question. What is a quantum? In physics, a quantum plural. Quanta is the minimum amount of any physical entity. It's the smallest possible package that any property can come in. You cannot have half a quantum. It's the ultimate small change of the universe. The fundamental idea that a property can only exist in these packages is called quantization. Let's make this concrete. In our everyday, classical world, things seem like a ramp. You can be at any height, but in the quantum world, things are a staircase. You can be on the first step, the second, or the third, but you can never, ever stand in between the steps. The property is quantized. It can only take on specific, discrete values. So where do we see this? The most crucial example is inside every atom. The energy of an electron bound to an atom is an electron can only exist at specific energy levels, like distinct orbits. It can't exist in the space between. This isn't just a quirky detail. It's the reason for the stability of matter. If electrons could spiral into the nucleus, all atoms would collapse. But they can't, because there is no in-between step for them to occupy. They are trapped on the staircase. And when an electron jumps from a higher step to a lower one, it releases a packet of energy. This packet is itself a quantum. For light, this packet is called a photon. A single photon is a quantum of light. Light itself comes in these particle-like bursts. This was the first shocking hint that light wasn't just a wave. The modern concept of the quantum has a precise birthday. December 14th, 1900. A German physicist named Max Planck was trying to solve a stubborn problem. The physics of how hot objects glow, known as black-body radiation. The classical theory predicted infinite radiation, which was clearly nonsense. In a move he saw as a mere mathematical trick, Planck made a radical proposal. He suggested that the atoms in the walls of this hot object could unvibrate with just any energy. Instead, they could only absorb or emit energy in tiny, discrete bundles. He called these bundles energy elements. It worked. The theory now perfectly matched the experiment, but Planck was uneasy. He felt he might have violated the sacred laws of continuous physics. In this process, he uncovered a fundamental constant of nature, which he called the quantum of action. We now know it as the Planck constant. H. This tiny number sets the size of the steps on the universe's staircase. For this world-shattering discovery, Planck was awarded the Nobel Prize in 1918. While Planck saw quanta as a property of atoms emitting energy, a young clerk in a patent office took it a step further. In 1905, Albert Einstein proposed that light itself is He said it exists as spatially localized packets, which he called light quanta. He used this idea to explain the photoelectric effective phenomena, where light shining on metal can eject electrons. The classical wave theory of light could unexplain why the color of the light, its frequency, mattered more than its brightness. But Einstein's particle theory of light could each quantum of light with energy. H could kick out a single electron. This work was so revolutionary it earned Einstein his Nobel Prize. So, what began as a desperate fix for a physics problem became the foundation of a revolution. The quantum is the fundamental unit of reality. Quantization is the rule that energy Light and matter come in discrete packets. This simple, yet profound, idea is the bedrock of quantum mechanics, which describes the world of the very small with stunning accuracy. It leads to technologies like lasers and transistors, and is pushing the frontiers of quantum computing. The next time you turn on a light, remember, you're not just flipping a switch. You're releasing a torrent of the universe's fundamental currencia, cascade of tiny, discrete, quanta, illuminating the true, digital nature of our reality. Thank you for watching. If you found this video valuable, please like and share this video, and subscribe to the channel.